A horizontal beam, as shown in figure, is hinged at point A and supported on roller at B. It carries a vertical load of 120 kilonewton at point D. Determine deflection at point D by taking E is equal to 200 GPa and I is equal to 160 into 10 raised to 6 millimeter raised to 4. Right? So you be very careful with the unit of I. In some questions, he will directly give the value of EI, right? E multiplied by I in terms of kilonewton meter square, right? So let me just see if there is anything. Yeah, you can see this numerical. It is giving EI is equal to 40,000 kilonewton meter square. So if you get like this, it's a lottery. It's very easy, right? But when you have these two in different units, you have to do proper conversion of the units. Okay. Now let us start solving this numerical. Now what I'll do is I just copy this sketch here, right? Now in this, let me consider a section. I'm using Mechale's method for solution. So I'm considering a section. I'll call this as XX, right? This as X, and this point I will call it as capital X, right? So this is the first thing that is told in the Mechale's method. You consider a section farther on the beam, very close to the support, right? Now at this section I will be finding the bending moment. Now from A, this XX is at a distance of X, right? So this distance is X. Let me just take this diagram to my Word file. Okay, so this is my modified diagram. Consider a section XX at a distance of X meter from support A, right? Now what is the bending moment at this section? Oh, sorry. First thing you need to do is you need to find the support reaction. Let me start from here. Support reactions. Now how to find support reactions? Sum of all the forces is equal to 0, sum of all the moments is equal to 0 on the beam. Now let me first take bending moment about point A, right? Now taking about point A, we get what do you get here? RB into perpendicular distances. How much is this? 1.8 plus 3.6, 5.4 meter. I don't know why he has given like this. So this is 5.4 minus, this is 120 into perpendicular distance is 1.8 meter, and that should be equal to 0 because this is the support. The bending moment at that point is 0. So upon solving this, you will get the value of RB. This is negative, it will go on the other side as positive. 120 into 1.8 is 216. 216 by 5.4 is 40 kilonewton. That is your RB. Therefore, RB is equal to 40 kilonewton. Now, sum of all the forces is equal to 0. RA plus RB should be equal to, there is only one force equal to 120 kilonewton. Therefore, RA is equal to 120 minus 40, so it will be 80 kilonewton. Okay, so I got my support reactions. Now what I will do, I'll just cut this. Consider a section XX at a distance of x meter from support A, and then I will write this. Right? Okay. Now bending moment at X. Bending moment at X is given by mx. The suffix there. Mx is equal to, right? At this section, I need to find the bending moment. So I have RA here, RA into X. What is RA? RA is 80 kilonewton. So I will put the value directly, 80 into X. So it will be 80X, right? And this is in downward direction. So this will be negative minus 120 into this distance, right, from D to X. So D to X is, dx is AX minus AD. So AX is X and AD is 1.8. So it is 120 into X minus 1.8, right? So, and this will be in kilonewton meter, because force I have taken in kilonewton and length I have taken in meter. So the bending moment is in kilonewton meter. I'll just leave it as it is. Also, we have mx, bending moment at any point, is equal to EI into d square y by dx. What's happening? Dx square. Right? Now I'm equating these two expressions. So what do I get? EI d square y by, or EI d square y by dx square is equal to this. Correct? So this is the equation which I have to integrate now. Now I have to integrate this twice, and I am using Macaulay's method for integration. integrating equation, we get EI remains as it is. So EI into d square y by dx square will become dy by dx, and that is equal to 80x will become 80x square by 2, correct? I'll just put a constant here plus c1 because this is the first half of the section, or I'll put the constant in the end if you want. I'll just leave it like this. Minus 120, that is a constant, so I'll just keep it as it is. Now I have to integrate this x minus 1.8. So you have to integrate this as a whole, right? You have to consider this as x and do not consider this as separate terms, correct? So when you integrate this, it will become x minus 1.8 whole square by 2, correct? That's it, plus c1. That is my constant of integration. I'm integrating this equation again. Oops. Again, we get now what will this become? EI into y, correct, is equal to, now this if you want, I'll just simplify this again. So this is equal to 80x square, so it becomes 80x square by 2, it becomes 40x square, right? So it becomes 40x square minus 120 by 2 is 60. So this will become 60 into x minus 1.8 whole square plus c, right? Now it's easy for me. So it is 40x square, integration of 40x square. So it will be 40x cube by 3, right? Minus this will be 60 by 3 into x minus 1.8 whole square is there, so it will become whole cube plus c1 will become c1x plus another constant c2, right? That is my integration. Or I'll just simplify this and just copy this as it is. 40 by 3, it will become a ratio, so I'll just keep it as it is. 60 by 3 will become 20. I'll just change that and rest will remain same, right? So I'll just call this as equation 1. I have one more equation here, right? I'll call this equation as 1 and this will be equation 2. Okay, now we have to apply boundary conditions on this equation and find C1 and C2. Now what is the boundary condition we are going to apply? At x is equal to 0, y is equal to 0, right? Applying boundary condition x, when x is equal to 0, y is equal to 0 in equation 2, right? That is this equation. See, in Michaelis method, always try to apply the boundary condition for finding the constant in the second equation. Don't try to solve first equation because we do not know the slope exactly where it is going to be 0, right? Only in simple case, like when a simply supported beam with a point load at center, I know it is at the center where the slope is 0. Other cases we are not sure, so better not try to go to this equation. Always try to apply the boundary condition in this and find the constant C1 and C2. Now let me apply this. So what will I get? We get EI into y. Y is 0, so this term will become 0 is equal to 40x cube. X is 0, so this will be 0. 20 into x minus 1.8. This becomes 0, so this term is negative. So I am ignoring this or dropping that term. Plus C1x. X is 0, so C1x will become 0 plus C2. In most of the cases, C2 will be 0 only, or C2 is equal to 0. My second constant of integration is 0. Now I will apply the second boundary condition. Applying boundary condition when x is equal to L, right? X is equal to L means point B, that is the other end of the beam. So y will be equal to 0. The deflection at the support is always 0 because beam is sitting on the support, it cannot deflect, right? So the deflection at the support is always 0. At x is equal to L, y is equal to 0. Now put the value of x as L here. Now what is L? L is, because I need the value here, L is 1.8 plus 3.6, 5.4 meter. L, which is equal to 5.4 meter, right? I am not trying to derive, I am trying to solve the numerical. So put the values. Now in this expression, I need to do it. So in equation 2. So what do I get? We get y is 0, so left hand side will become 0 is equal to 40x cube by, I'll just copy this. So I am going to just put value of L at all the places. So x is 5.4 meter. Okay, it becomes very confusing. I'll put it into here. 40 into 5.4 cube, and here this will be 5.4. 5.4 minus 1.8 is not negative, so this will be there, and C1 into 5.4, right? This is equal to, let me calculate these values. 40 into 5.4 cube by 3, 2099.52 minus 5.4 minus 1.8 is 3.6. Cube is this much into 20, 933.12 plus 5.4 C1, right? Or C1 is equal to how much? So 2099.52 minus 933.12 is this. So it is a positive value. When goes on the other side, it will become negative, divided by 5.4. So C1 is minus 216. Minus 216. Right? Now you put the value of C1 and C2 in equation 1 and 2. Put C1 and C2 in equation 1. We get, what is equation 1 we had? Where is 1? This is equation 1, right? So I will just copy this entirely and paste it here. EI dy by dx is equal to 40x square minus 60 da, 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 and C1 is minus 216. So I'll just replace this minus 216. So this will become equation 3 now, right? So equation 3 is the general slope equation. I'm just abbreviating this to save time. So you can find the slope at any point on the beam using this equation. Now again you put C1 and C2 in equation 2, right? Where is my equation 2? This is my equation 2. Just copy this. C1 is minus 216. So this will become minus 216 x, and C2 is 0. Neglect this. Oops, time is up. Right? So this is my general deflection equation. In this, I'll just make one more change. 1 by EI into, I'll open a bracket and put everything there. And here, I'll just cut this. One by EI into this. Now this is equation 4. Equation 4 is general deflection equation. Okay, GDE GSE. Now in this, you just have to substitute the values and you will get the deflection and slope. Now what is the question? Question is determine deflection at point D by taking E and I as this value. So in this expression, you put the value of x as 1.8, right? That will give you the slope and deflection values. My meeting may end. I'll just quickly take a snapshot of this again. Strength has decreased a lot. Yes. So now let me just do this. Deflection at D is equal to x is equal to 1.8 meter. So in this expression you put x as 1.8, you will get the value of deflection. Now I have to calculate. E is 200 GPa, so it is 200 into 10 raised to 6, and I is 160 into 10 raised to 6 mm raised to 4. So you have to multiply this with 10 raised to minus 12. So when you multiply with 10 raised to minus 12, it will become 160 into 10 raised to minus 6. Here it is 200 into 10 raised to 6. 10 raised to 6, 10 raised to minus 6 gets cancelled. So it is just 200 into 160 kilonewton meter square. That will be your EI. Did you get that? Right? So I will just copy this. This will be 200 into 160. This is 1.8 cube. Here 1.8 minus 1.8, this becomes 0. So I'll just put 0 here into 1.8. Let me just calculate quickly. 1.8 cube into 40 by 3 is this, minus 216 into 1.8 is this value, by 200 by 160.